Hi everyone, we're going to graph this function f of x and also test for continuity at x equals -1 because that's where the changes are happening. So the first thing we're going to do is test for continuity, and there's your equation. So the definition of continuity means that it must meet these three conditions. So basically, condition 1, we want to know if our function here is continuous at x equals 1. That means that's our C, continuous at x equals 1. So we're going to do f of not 1, but -1. So we're going to do f of -1. Now, where it equals -1 is in the second portion. So I'm going to plug in -1 here. And this equals -4. Because that's -3 minus 1 is -4. So we do have a value of -4 at x or c equals -1. Now we have to see if the conditions exist too if our limits equal each other. So that means the left-hand side has to look like the right-hand side of our value. And I'll tell you what that means. That means if you take the limit, and don't worry about the limit part. So our c is -1 of our function. From the left, that should equal the limit as x approaches -1 from the right. And that is so sloppy there, so let me do that again. So as x approaches -1 from the right of f of x. So let's check this one. So all numbers left of -1, that is this upper portion. So whatever it is, all numbers are going to equal what? -5. Now, all numbers right of -1, that means you plug the -1 into this one, which we already did, and we got -4. It looks like these two do not equal, so this does not equal. That means that the limit does not exist, so it fails condition 2. That means this function we're about to graph is not continuous. So here we go. We're going to graph it. So at -1, this is where all the action's happening, to the left, all numbers to the left. If you plug in -1, we're at -5. So 1, 2, 3, 4, 5. This is -5. But it can't equal it, so I'm open. It can get very close to it, but it can't equal it. Now plug in -2, and it's still going to be -5, and so forth. So it's going to, whatever we plug in, all values left of -1, it's going to be -5. You get very, very close to -1, but it can't equal -1. Now, when it equals -1, we were at -4. So that was right here. Right here. And now I'm going to plug in 0, because you need 2 points to make a line. You plug in 0 here. We're at -1, so right here. And you need 2 points, so there's your line. We have a slope of 3. 2, 3, 1. It's linear, so whoops. Just kind of goes straight there. It's kind of hard to draw on this, but I'm not an artist. All right. So there you can see why it's discontinuous, because if you start graphing from the left to the right, you're going this way, but right when we get to this point, we have to lift our pen up and go there, and then draw that line. So this is called the jump discontinuity and continuity, and that's why the condition failed. Condition 2 failed. That's it. Thank you. Have a nice day. Bye-bye.
Class, Miss Shaw's class. Boy, I love math. Miss Shaw's class, Miss Shaw's class.
Don't fail. Watch Miss Shaw's videos for free.